Uh, Give me a second. Okay, I forgot to remove the overlay. So, welcome back to this Global Hack Week. This is my first stream from this Global Hack Week. These are busy days. I think I can speak for all. I mean, we're on the close of the year. So, thanks again for showing up here, for joining. I'll be very pending to your comments. Actually, I'm going to move my main screen here so I can talk more directly with you. Um, Let me introduce myself because I always forgot to do this. My name is Alberto Camarena, and I'm your Mayoli hacking coach from Mexico. So I'm really happy to be here, and I'm really happy to showcase this stream I have prepared for you. Here it's the check-in links, so please don't forget to check in yourselves here at event.mlh 1342.9 so you can win your community points, right? Also, talking of, Carrie couldn't make the your first ML model part two. She was not feeling so well, so hope Carrie um, gets better for tomorrow part three, right? After me, we have using open source LLMs with me. Um, that's a complicated time zone for many. It's at 3 a.m. ET time, but I'm sure that also it's a really great time zone for others, right? I don't know why. What time is it for you? For me, it's 8 in the night. So a really good time just to spend here and learning about, why not MongoDB vector data, right? So, oh my god, now I'm going to prepare everything to start sharing my screen. Give me a second. Huh. Yeah, give me a second. I'm exporting these slides I'm going to use. Um, Remember, I use Mark for this, so I was just finishing this up. I'm going to export, and let's open this. Oh, it opened in a wrong space. Okay, and you should see my slides. Oh, I'm not sharing screen here. I said, give me a second for that. Okay, you should see my screens now. Great, MongoDB vector database. And let's start with this. The learning objectives and what I hope you get at the end of the session is that you understand what a vector database is and why does this matter, right? Learn how to use them, learn how the vector database searches from, the amount of data that you have, and also how it differentiates from the traditional database. Understand the concept of what a vector embedding is, learn how specifically MongoDB uses this, and what the Atlas has to offer. Atlas is the fully managed cloud service of MongoDB. And why not? Let's start building some practical applications for semantic search and recruit argument generation. If you're not familiar with any of these two concepts, don't worry. We'll explain a little bit more about this. So, what is a vector database? And for understanding this, I think it's worth mentioning the traditional database or the relational database that we probably are familiar with. So, these are tables, these are rows and columns, right? So, the way of thinking in traditional databases or relational databases, it's like that, just tables. Um, If you're like really really new and haven't heard of this before or don't know how that relational database works, basically imagine a spreadsheet or an Excel file, and that's it. You have columns with specific attributes of your system, and rows being every input or every entry of your system. This has many challenges, like having to connect many tables with foreign keys, private keys, to extend the schema of our integrations. Um, there are things like ORMs, object relational mappers, to have the ability now to translate these database language into what we do at the code stage, which is objects, right? So we use the object-oriented programming in many cases, in many languages. There's a discrepancy, there's a disruption, there's no good communication between these two pieces of software. Now, imagine having the ability of using, same as that, the objects you are thinking, the entities that you are planning for your application in a flexible way, that you don't need to define many tables. You can define just a document. That's how MongoDB works. um, Also, you don't need to define a schema. I mean, you can, but the ability to have that schema flexible, to be constantly updating over the evolution of your application, that's another thing MongoDB has to offer, right? And one of these many advantages is that, for example, in the traditional databases, you can store many types of data. For example, text. But the problem is that when you search for this using queries, uh, the search capabilities start to being like not that good, right? Because you have mismatches if you're not looking for exact words or exact keywords or index, sorry. Um, but what a vector DB has to offer, it's that it stores a high dimensional vector in a form of arrays of numbers that can search by similarity. The key idea here is that similar concepts are represented in the same space, right? So remember your classes when what's a vector, right? Let's start to understand that first. Um, okay, yeah, what's a vector? In pure mathematical concept, it's when an array of numbers can start with a sequence. For example, if we have that two-dimensional space, we have x and y. If we have a point in space, it has a value in, for example, 0, comma 1, right? It will be here if this is the 1 and this is the 0 in x, in y, sorry. If we have 1 comma 1, we have 1 in y and 1 in x, and or that is going to be here. A vector has an starting and an ending point, at least, right? It could have multiple points, sorry, that connects in the whole trajectory of the vector. But yeah, that's the main principle. And what happens here, and the term of the vector database, it's really similar because of that. We mentioned the high dimensionality because two dimension it's really easy to understand, but in practicity it's not that simple, right? We need more than, I don't know, n number of dimensions that we can understand in coding, but we cannot represent that easily, right? I see we have some comments here. Eclectic says hi, and Juan a eighth Matt says hi or hello also. So great to have you here, guys. Thanks for joining. So understanding this, For example, returning to the two-dimensional space, if we have one vector pointing this way, but other one pointing this other way, means they are opposites. So the direction they're aiming, there's the complete opposite. If we imagine this, for example, for representing the movement of a car, the y being, for example, speed, and the x being, for example, the position, we can say the car is moving forward. The other vector would mean the car is moving backwards. Again, two dimension, it's really easy to understand. But for example, if the one vector one it's pointing like this way, upside, and the vector two it's slightly more pointing to the right, they mean similar things. The two of them are moving forwards, one with higher speed than the other, right? But it makes sense, right? I hope it makes sense. If not, just let me know here on the comment section. Uh, and with vectors in the databases, this could be the same. Imagine you get the assignment to analyze the movies in the Netflix database, right? And they ask you which movie is more similar to, I don't know, Shrek. And they ask you what other movies are similar to Shrek. Well, you can start like thinking of how with your traditional database you could do this. I don't know, like try for the authors. Maybe the authors do the same things or similar things. So you get this author for Shrek One, and probably the same author is for Shrek Two and Shrek Three. They are similar, but they also made and I'm going to say the author, it's just DreamWorks. They also made I don't know, the what's the other movie? Puss in the Boots. Yeah. So your recommendation system says, okay, you should see this other movie because they are the same authors, right? But imagine if you want to look for the I don't know, again similarity but based on the topic of the movie, right? At least if this is not tagged and it's not metadata um, in your object, this could be start getting hard, right? um, so this led me to the next slide. What is sorry Why vector search? And this is really important. We can have missing synonyms. For example, you can type in your search bar, I want a car, but maybe in the database it's stored as an automobile or as a wheel machine. I don't know, many other words. We know because we're humans, these are the same, these are synonyms. The computers are not smart enough to just tell these are synonyms, right? They need an extra layer to understand that. They have no context of understanding. For example, here we can type for apple, and we could mean like the fruit or the company. What do you want? Well, the benefit of a vector search as is that it has semantic understanding. It doesn't only store raw text, it has meanings, not just the keyword. It also has multi-language support, right? And not only multi-language, multimodal. And this, I can say, it's why I am doing this over MongoDB and why this is relevant in these terms. Because yeah, there are many vector database out there. You can just Google vector database. There are pretty popular ones, but the multimodal one and having the ability of storing these on MongoDB, I think it's one of the best because MongoDB doesn't require you again to have predefined schemas. It doesn't fight the different types of information. It does not makes you move mountains, the sky, and everything just to make data fit your database. Your database fits your data, and it's like that. Also, uh, talking about this last point, the context aware, understand the intent and the relationships. Here again, two dimensions. It's easy to understand. The final arrows of these vectors point in the same direction or the same vector space with three dimensions. If we do this, it's a little bit more complex to represent, but we also can understand this because we're three-dimensional people. We live in a three-dimensional space. More dimensionality in our understanding of visual representations. It's not that simple. It's not that accurate also, but for the computers, it works, right? And this high dimensionality tells these intent and relationships between the data. This is not easy, I have to say this. We cannot just translate a movie like Shrek into a vector embedding with, I don't know, an addition or converting the each pixel of the movie into bytecode. Uh, Again, it's not that simple. We have things called embedding models, right? These embedding models are another thing we're going to discuss during this session. But I also worked, and I know you are shy, and that's why you haven't asked me. But what do you mean, Alberto, with vector embeddings? Well, vector embedding, it's the numerical representation of this data I am talking of, or we are talking of, right? But again, it's not like just saying, okay, how do I represent a cat? Uh, and I draw in matrix an image of the shadow of a cat, right? It's not how that works. It converts the complex data into these arrays of numbers, capturing the semantic meaning in the high dimensional space. Each direction or each dimension in this high dimensional space could have a meaning, and we need to understand it. That's part of the AI and the research in progress of explicability. We pass this over AI machine learning models, and we receive the M2 embedding, the vector embedding. What's happening there? That's very interesting, and I think it's worth just talking about this. I could say a whole session. So again, the key concept here, it's similar meanings have similar vectors, right? Does that make sense? They had to because they follow the same route. For example, a vector for a cat uh, can be very similar to the one for a kitty. But also, in certain ways, it is also very, very similar to a lion, for example, or a cheetah, more than it is for a dog. But it is more similar to a dog than a than it is to a car, right? Again, hope this makes sense. It's also kind of very intuitive. And why this is intuitive, and this is also one thing I want to share with you and have you stick in your mind for the rest of your lives. If a computer already is good in something, then it does not require artificial intelligence. Artificial intelligence it's for what people or humans are good into, but computers are not. For example, understanding this difference between a cat and a kitten, understanding that a picture of a dog is a picture of a dog. When hearing something, understanding if it is French, if it is Spanish, also if it is mispronounced, if it is pronounced like in a different accent, those kind of things. And it's very interlinked with the multimodal example I was talking of, because when we pause things, when we feed the computer with text, for example, that can be in between quotes easily translated into the bytecode, well, the computer knows what to do then, right? But we have to design different techniques for computer vision, for speech to text, for um, what else, creating images, those kind of things. And I said between quotes the part of the text, because yeah, when it's a programming language that has predefined rules, everything works fine. That's just text, plain text, and then it's translated to bytecode so the computer can understand it. But when it's natural language, it's difficult, because words have intentionality, words have uh, um, they said this as a color, as a temperature, right? I can say I'm so angry, and since I am talking, you can tell, okay, Alberto, it's not angry, it's he's just saying he's angry. But how a computer can actually tell based on the context, that's a really challenging thing for a computer, not for a human. um, who generated these vectors from a given input? Who generates these vectors for a given input? Us. Like, if you're talking specifically about the example, no one. Like, no one is doing this. It's just an example. But if you mention for the real use case, how this works, and I have a really good image showing this workflow. It's that you get the input, you get your, for example, image of the kitty, and then you pass it to the embedding model. You receive the embedding vector, you storing into database. That's the Mongo or any other that we're mentioning. There exists any other vector databases. And then when you need to access that information again, you need to pass it again to the model to understand what's happening, right? So that is a great question. Um, Good morning, bro. Hey, good morning. Yeah, you mean the real use case? I hope I answered that question. So again, how the embedded works. This is part of your question. You input the data, it passes through the embedding model, it processes the data, you get the vector embedding, which is the output, you store it in your database, and then you perform a similarity search to find relating items. Uh, this 5 step, it's the one that's really interesting on how Mongo does this, in difference to the regular process of how other databases performs this, right? Also, I want to talk about the re-ranking models, or re-rankers. What are they? Well, they works as a second stage refinement process for the results. Takes the initial result and reorders them for better relevance. Again, this, it's like applying extra layer. This is optional, this can be removed from the first equation, but you do get better results. So it improves the accuracy without changing the initial search. Why do you use it? Again, it's up to you, but it can give you better precision, efficiency, also flexibility, and if you're in production, and this is relevant to you, a cost effective, because in the long term, this is cheaper than using and than having to re-embed everything. And this is what I'm meaning with the having to decode them, right? So the original data and the question both needs to be converted to vectors. Oh, I get what you mean there, like how you perform your query. We're going to do that in the workshop. So keep a pin on that. And if you keep having the question when we're done, we can revisit that. But uh, sure, thank you. Okay, yeah, no worries. Vector search. Okay, I'm going to talk about the Atlas vector search, and that's specifically what you're questioning, Juanaid Ma. Also, we have P3 engineer girl. What are the similarities, difference between numerical vector embeddings and binary? Um, that's a great question. I would say binaries perform well, but it will depend. If we meant in the storage part, uh, I would say the binaries probably take more space, but the point it's not on the storaging. It's actually the magic happens in the embedding model you're using, and many embedding models, and we are going to talk about some of them, but it's specifically one that it's the one we're going to use. Uh, have different ways to approach this. So I'm not sure, to be honest, of your question. That was just a guess about the storing cost in terms of memory being higher for binaries. But at the end, it's just a matter of the performance on the benchmark of your. Em- Sorry, I forgot the word. Of your embedding model. That's it. Um, yeah. Okay. So for the Atlas vector search, sorry, I lost track of this. Let me drink some water. We have native vector search available with MongoDB. Alternatives, you can use Elasticsearch. Uh, yeah, no separate infrastructure needed. That's another thing that I like to highlight, because we will see that everything we have mentioned this far comes already pre-built in with MongoDB. So if we need to combine the vector search with traditional queries, with our database schema of the entity we're talking of, then insert an embedding and look for everything. That's older. That's simply older. Regular workflows for other alternatives needs, like, you need your operational database to store your entity, and then like a private key or something that relates that to the vector embedding in your vector database. Then you need to translate that or have a pipeline connecting everything, then search engine just to see what's happening there, everything connected, everything complicated to store. So that's another thing I like to highlight about MongoDB, and specifically with this capability of Atlas. um, so let's set up Atlas vector search. Before we move to the actual doing this in my computer, I'm going to show the this is how the vector search looks. Oh my god. This is supposed to show an image that it's not showing. Give me a second. Hmm. I wonder why it's not showing the image. But hey, doesn't matter. I have the image here, so I will show you anyway. Okay, here it is. Hopes you can appreciate this. So, for example, this is what I was meaning here with the not separated infrastructure needed. So, if we perform a query previously, we have to do the pass the query to the embedding model. Also, feed the database with the unstructured data, pass it to the embedding model, store it in the vector database. So we start here, we store that in vector database. We connect that with the ranker to our LLM, and we get the contextual rich grounded response. Um, with MongoDB, and thanks to the acquisition that was just recently made to Voyage AI, now we have our unstructured data, our embedding model, our vector search, and our re-ranker at the same place. So I think that's really powerful because now we just need to connect or have to worry to connect to our long language model, and we have the contextual rich ground response, right? Same, the query comes natural in this way. Well, thanks for that. So I don't know why it's not being shown here. That's my bad. But actually, yeah, and I mentioned this. It's the state of the art embedding model. Well, embedding models. Also, it's specialized for retrieval and search tasks. It's high quality embeddings for various domains. And why? It's accurate, it's fast, it's flexible, and it's enterprise ready. So it's very reliable. That's why I mean with that enterprise ready. Also, this is bad. I'm sorry for not checking if these slides were collapsing. Um, but we are going to get to the use cases, right? We're going to build a semantic search engine and a retrieve augmented generation project, right? I don't think we are going to reach this point. We will see. It will depend entirely on us and how participative you are. But the one I am for sure we're going to reach in and build it's the semantic search engine. So let's get our hands into that. Let me close this. Yeah, the repository. I think I didn't show this. Uh, I'm going to share the repository at the end. There, then you will have the slides and the code for everything. So don't you worry. I will share this at the end of the session. Uh, okay, for the semantic search, we have a README prepared. So semantic search engine with MongoDB Atlas Vector Search. This project demonstrated how to build a semantic search engine using MongoDB Atlas Vector Search and Voyage AI embeddings. Uh, to understand prerequisites, we're going to use Python or Node. In my case, I'm going to use Node, but just to let you know, like this works pretty fine with many languages. Um, MongoDB Atlas account, the free trial works, but also if you look for, let me MLH dot link slash MongoDB. Let me copy and paste this to share with you. If you come here, you will see that we have, in my case, I'm already logged in and I have already claimed my $50 for Atlas credit. But hey, you have this for you. Great. Go and claim it. This is thanks to the GitHub Student Developer Pack. And so if you haven't claimed your GitHub Student Developer Pack, please go and do it. The same, it's I think the same except of MongoDB GitHub, right? So go claim your uh, free $50 of credits if you already have your student developer pack. If you don't, go and claim your GitHub student developer pack. That's simple as it is. Also, another benefit, you have a free MongoDB certification. So complete an entire certification learning path on MongoDB University. You will receive an email with a $100 discount voucher And well, that's it. What it's inside these certification learning paths? Well, they have plenty things. Um, these all are learning paths, and they give you like great certifications. For example, MongoDB Atlas Administrator, administrator for the self-host version, which is the Mongo database admin path, the PHP developer, Python developer, Java developer, Node.js developer, Mongo C Sharp developer, and data modeling part. I really recommend this data modeling one because it helps you understand like the design patterns for MongoDB, the benefits and difference from the relational and the traditional databases. Um, so yeah, my go on at least for this will be the data modeling. Um, Another quick highlight I would like to give it's about the skills. Let me remove a little my tab here. Um, yeah, sorry. Here it is. We also, despite the learning paths, the MongoDB education team actually have made a really great job. If you look for learn.mongodb.com/skills, you can find not full learning paths, but small skills. I'm going to share this here with you. Here you are. uh, Career changing skills, 90 minutes. It doesn't take you that much. They have around the data modeling, generative AI, query aggregation, security, index sharding. If you don't know, for your design system interview, this will help you a lot. Monitoring, turning, and automation, search performance at scale. Also, another one great for your design systems and architecture. Um, mm, mm. Also, these are great if you like to display those on LinkedIn. For example, you learn, you validate, and you earn a claim badge from Credly. I've seen very actively in LinkedIn that the MongoDB page is like constantly sharing and saying congrats to the people that actually get this done and share them. So these are really cool. You have a badge, which is like an extra benefit. Oh, I think I hit that video. Um, yeah, that's another thing I wanted to mention. So let's close this and start opening. I'm going to open Atlas MongoDB, Atlas database. I'm going to sing in. Okay. Okay, this is for my organization, which is a test one. I have now a running cluster. Right now, I don't have a search, picture search, edge visualization. Okay. Just let me take a look to the cluster. Yeah, I have a cluster 0. Yeah, clusters, rows collection. What I have here. I think this was for the previous global hack week. I am not sure what this contains. We will discover admin, nothing here, local test clients. Oh, we have, yeah, I created this for a task. Uh, let's finish this with run task development 32. Okay, uh, no problem. This was like just the dummy test. I think I can get rid of this, but later. Mm. So we have our Mongo Atlas account, right? I hope you already have yours. Is it for free? Um, Creating your account, yeah, it's for free. Also, per account, I think you have an M0 cluster. What's that? Like the free tier version. Um, Actually, that's a good one. Let me delete this cluster. And why I'm saying this, because for example, if I want to create a new one, right now the versions I have available, they're like M30 per hour, M10 per hour, or flex. It can scale depending on what you want, right? But these are not free. I mean, we have the credits, we can play with them. Uh, but this one I have running here, it's free, and I'm going to terminate it. Cluster 0, so you can see how I turn up a new one. That will be an M0, which is a free tire, and then that will be completely free. And you mean if sorry, I should start reading more, like the second comments. The following message was the MongoDB certification and courses. The skills one, yes, they do. I think it's oh, learnmongodb.com. Um, all the content that it's as here, for example, skills that it's pre-recorded and everything it's free. If you want a certification for the path, the one that the I show next to the $50 credits, those are not free if you want to get the full certification, right? But they give you one for free, the voucher I was meaning. That's worth of, I think, $100, something like that. Also, they have instructor-led trainings. These are like, you connect via, I'm not sure if this is Zoom or something, but you connect in internet for instructor-led training. So these ones also are not free; these are paid. But my God, I clicked them. But here on the learn.mongodb, you can see, like, for example, this is paid, this is free, this is paid. All the certification, for example, to certify yourself as an administrator, uh, how much it will be. I'm not sure about the prices. Well, uh, sure, okay, but they have a price. Um, for the skills program, this is kind of new. Again, these skills are free. And also the badge you receive, that's also free. That's not something they charge you for. Um, but you see, like, all the instructor alerts are paid ones. The self-paced learning, they are free. These for learning pad, you can take the learning paths. That's the thing I wanted to say. Like, you can take them, but if you want the certification, that has a cost. Okay, great question. Thanks for asking. So uh, right now I don't have any cluster. I can build a new one, and now I have the free one, which I don't see right now. This is called M0, but hey, these are M0s. Last time I checked. So if I see I have only half gigabyte of storage, not even 8 gigabyte completely, shared RAM, shared BCPU. So you see, this is really very limited, but it's great for these teaching educational purposes, right? So let's call these a MongoDB. Or no, let's call these Global Hack Week Showcase. Oh, I can. Okay, and I want this to be on AWS. Yeah, I'm going to host it on Aragon, and I'm going to create a deployment. This doesn't take that much time, but hey, it will be ready in just a matter of seconds. Could you please share the GitHub repo link for the hands-on so that we can try to do it alongside? Oh, we are going to build this alongside. I mean, as you can see, I don't have this code created, so don't worry. That's also why I'm not sharing this, because what we build during this session is what I am going to share. But if you mean for the instructions, yeah, I can. Yeah, give me a second. I can do that. Okay, now let me open GitHub, and I'm going to create a new repository. And the repository name I described here, it's this one. Create repository. Oh, great. Switch main. Great. Now this is the repo. Already should contain the markdown file. Yeah, the README for each port. And here you go. Great. Great, great, great. Okay, there you go. Let me now close this one. Yeah, the semantic search. We were talking about this. Create a Mongo single for free account. M0 cluster is enough. Then we create a new project. Um, Here we have the build database, which is the M0 free trial. We already do that. This is already here. Select your preferred cloud provider, blah blah blah, and configure network access. Okay, that's another very important thing. One of the most common issues I see when at a hackathons, people say like, "Hey, I can connect to my MongoDB project." Well, you need to check on the database access here on the left part, on security, database and network access. As you see, I have one admin, my Atlas DB user, test user one. I'm going to create a new one, for example, with a password. In this case, we can add more granular things, certifications, I am in AWS, those kind of things. I am going to keep it light. I'm going to say test user 2, for example. I'm going to auto generate a secure password. I'm going to copy this. And I'm going to create this. Also, MongoDB Atlas has really good base roles privilege, so we can add a built-in role. Right now, this doesn't have. Uh, so I'm going just to give a Atlas admin in general because we're going to use this. Uh, Custom roles, specific privilege, temporary user. Okay, this is great. I'm going to use this just for the day. Enable to specific resources. Okay, no worries. I can add the user. Also, I'm going to delete these previous ones. Yeah, I'm not going to use this. Yes, you can see for the roles, these my Atlas DB user only had the read, write, any database as admin, but you see, you can manage your roles. Um, okay, and before I forget this, I'm going to create a dot, and I'm going to paste this here. I'm going to add a base dot git ignore, and what else? Okay, let's continue. Um, Rhythm. Oh, and the other thing, yeah, about the security. On the network access, you will see we have not only the users, but again, our specific roles. In my case, I don't have a custom role. I don't need to for the moment. And the IP access list. This one was created as part of the auto setup process. Also this other I can't remember because this is a project that has been running for many time when I added these two, but also I added the 0.0.0, which is everyone at any IP address can connect to this. um, is this recommended for production? Is this recommended for your projects? It is not. And at least on a building stage, you can do this, so you can easily connect. That's another thing that you need to have in mind. So I do recommend setting up this on the configure network access at the new IP address and allow access from everywhere. Again, for production, use specific IP addresses, not in the development. There's not that much a problem. Also, if you're using the free tier, if you're using your credits, just make sure your friends or anyone like in internet that you're sharing sensitive information, that could be a problem. Um, yeah. So we add that, we create the database user, then we need a connection string. So we mentioned we were having this here. So I'm going to create a MongoDB URI. Um, this is going to be get from the cluster, and you can see we have a connect. Let's connect, and we have many ways to connect. Toward the tools like Compass, the Shell, MongoDB for VS Code, Atlas SQL. There are many, but we are going to connect via a driver. What is a driver, you may be wondering? Well, in difference to SQL databases, MongoDB doesn't require a query language. So it allows you to perform queries and everything you need to your database in your favorite language. So if you use MongoDB, if you use MongoDB, you can use your favorite programming language as Python, as Node, as Ruby, as Java, as C, C Sharp, C++. Well, C, no, C Sharp or C++. Um, yeah, so That's how you do it. So I'm just going to select the driver for Node.js. We have many others like C, C Sharp, C++, Go, Java, Kotlin, Mongoose, PHP, Python, Ruby, Rust, Scala. So I'm going to just select Node. What version do I have? Um, 6.7 or later. How we install this, we're going to have to do this later, but here is our URI. So, only thing we need to replace it's the password. I'm going to replace it now, and the database username I'm going to replace it. It was test user 2, right? Simple as that. So really simple. And if you're getting started, you can also run it with a sample app. So that's crazy. And also here on the view full code sample, uh, you can make sure that you can test this. I mean, I'm just wanting to get the URI since this is not going to be part of the code. I'm not going to hard code this. It's going to be on an environment. Um, require Mongo because we also install this as a package for JavaScript, right? Um, if you're doing Python, it's the same. You need to install with pip and have the Mongo client and the server API with PyMongo. What are is popular? I think Java. In Java, you need to import conf.mongo.connection string, all these libraries, and then use it as this. So again, I'm going to reset my default to Node.js. Any questions this far? Please let me know. Okay, now we have our connection string. Step 6, it's to create database and the collections, browse collections on your cluster, add my data. In this case, we are going to host this with sample data, right? Sample data says and search index successfully loaded. Why does this happen? Well, MongoDB is smart enough to know we're using these for education purposes. So let's take a look to the collections. Let's browse our collections, and we can see um, we have something called sample mflix, right? What does that sound like? Well, I'm not going to say it, but we all know what it sounds like. So we have comments, embedded movies, sessions, theaters, and users. How does the users look like? Okay, they have a name, they have an email, they have a password. Um, theaters, they have a location, which is another object, having an address, which is another object, geolocation, which is another object, with coordinates like this. Well, first, movies. We have the plot, a group of bandits stage by a brazen train or hold up, only to find a blah blah blah, right? An array of genres. For example, this is a short, this is a western, an array with the cast for the cast, an image for the poster, a title, The Great Tyranny Robbery, the full plot, the language. This is an array of all the languages that this is available. Release date, which this is a timestamp, directors, and also an array. And I'm going to reach no. Okay. Embedded modules. This is one that's interesting. It is the same information. If you can see, like Scarface, we have blood, genre, runtime, rated, cast, Netflix comments, awards, writers, everything. But we also have the plot embeddings, and the plot embeddings with Voyage 3 large. What is this? What is this? Well, this is what we needed. That's simple. If you don't find this when you create your M0 cluster, I'm pretty sure that you can find on your clusters the, this should be a button around here that says import data or something like that. Explore short demise. Hmm. No, real time metrics. Online. Here, load sample datasets, and they have more. For example, there is the sample supplies, sample Airbnb, sample analytics, sample geospatial, sample guides, sample restaurants, sample training, and sample weather data. Right? We already have the sample flicks, so there's no need to load it. It's currently loaded. Um, hey, I just see a new comment here. My team is looking to build a RAG system as a chatbot for a university website. Can you suggest how can we convert the website text to a vector DB? Yeah. Um, Again, we are going to do that. But the easy answer, it's come here, look for Voyage AI, and this is how. It's really simple. And then you store this on your database, right? Again, oh, I I think, yeah. I think I removed this, but here on slides and images, MongoDB, here is the thing you were meaning. Like, you have your unstructured data, which is in this case it's the text you want to convert. You pass it to the embedding model, you get your embedding vector, and you store it in your vector database. Um, it's that clear enough, Abdul? Let me know. Okay, let's return here. And okay. Uh-huh, Here, embedding model, vector DB, re-ranker, relevant funds, LLM, factual. Wait. General purpose models, domain specific, company specific, high accuracy, low dimensionality, voyage API, cloud providers, trust. Let's see, let's see. Um, okay, I think they try now. I hope this takes us to the general purpose models, clear static, voyage API. Here, the API. So, quick start tutorial. Your Voyage API keys. Mm, Here, for example, Abdul, this is another great example of that. You have, they call this corpus, but your storage of files, um, being your, yeah, your file storage. you pass them to the embedding model. You have your documents and the embeddings to the vector store, and then you pass it, retrieve to the generative model. That could be Gemini, for example, and then you get your response. Why I'm saying Gemini? Because remember, we are mainly hacking and partnering up with Gemini. So I also Gemini 3.0. It's like amazing. Um, so you need to prepare your data, vectorize the embedding documents. This is how embed the documents. Uh, Notes on the tokenizer, a minimalist retrieval system. Blah. Okay, okay. This is the overlook, right? So let's continue with what we were doing. We cover the simple data, right? So we already have our collection and our database. We have that. We need to create a vector search index. So in the cluster, we go to the Atlas Search tab, and we need to create the search index, right? So cluster, search, and vector search. Let's see. Test your index with a query. So let's create the test query. Query editor now has templates. Oh, great. And also very educational for different queries and support running search meta queries. Open query editor to check it out. Okay, let's see. Create from the template. Ooh, this is fancy. Access templates for queries here. Got it. Okay, got it. Oh, oh, this is not disappearing. Okay, we can search with typos. We can get conditional results. Search as you type with partial matching. Categorize query search. Customize search scores. Oh, mm. Okay, template text. Let's insert these of searching with typos. I think that's the most easy to appreciate. Okay, that was great. So we search on index at default the text we want, and we query it's the search string field. The path it's the field to search. So let's explore our data a little bit again. Uh, okay, search tester. Ready queryable. Use editor below to run a search and search meta queries on documents from sample Netflix movies using your search index. Search queries return up to 10 documents ranked by score. Search metadata returns a meta document to queries which stages after search visit the aggregation pipeline. Okay, that's interesting, but I don't see. Are these the? No, these are the results, right? Uh, I think these are the results. I'm going to open the cluster in okay. I'm going to open uh, Compass, which is the graphic interface for this. Start. I'm going to add a connection. So let me go back to my cluster. I'm going to connect. I'm going to connect via Compass. I don't have Compass. I have Compass install. Uh, so I'm going to copy this, add a new connection. My connection URI is this, the same actually. I accidentally hit connect, but I didn't want it to. That uh, okay, yeah, this is. I remove that connection. I'm going to add the new connection, but something's changed. In this case, uh, this is blue since this is, yeah, save and connect. We're going to see what we have, um, which is the sample flicks, and this is supposed to look on movies. So I'll try on the title. So let's see the capabilities here again. Search, vector search. Let's query. Let's create the fuzzy search with typos. Uh, what we are going to look for here, it's the path. The path we want, it's countries. No, sorry, title, and the query itself. It's going to be, so for example here. No, let me cancel this, and I'm going to add the title, and I'm going to look for, let's look random one, title 1 week. If I hit here 1 week, correct spell, this got me something. We have one result with that query. If I for some reason hit 1 week lowercase, suddenly I don't have a 1 week movie, which is expected. I mean, this is how normally things works, right? Uh, but let's try with the 1 week here. Let's search, and we have many different. For example, these awards win nominations with this win ID 2A. So let me do a query based on the ID, and we have that. This is the movie that we wanted. I don't know why this is just showing me some awards cast. Is that something I want? Index default. No, no, this is not. But we can. My bad. The interface is not that great, but the functionality, it's like magic, right? So we have now fuzzy results. What fuzzy means, and I love this concept. Um, we know mathematics; it's correct or incorrect, right? We have the result or no result at all. That's a binary logic. One, it's one, zero, it's zero. But what happens if we want fuzziness? If we want something that, well, it depends. If it is 0.9, it's true. If it is, again, one, it's true, zero, it's false, right? But if 0.9, then it can be true. If it's 0.4, then take it as a false. When we draw the line, those are the interesting things. And we can set that up. For example, max edits, preferred length, max expansion, characters on fuzzy. Want to learn more about this? Let's take a look to the operators are collections. So for the fuzzy, to complete compound equals exist, search exist hazard. Okay, here. Oh no. Okay, let's see. Text. Okay, here. Yeah. Search operator. Fuzzy. What options we have at that? Fuzzy example. Max edits allow up to two character validation at each term. Max expansions consider up to 50 similarities. Prefer length it's disabled. Yeah. The query also includes a limit to get the output at the resource. That's a great thing to explore. For example, if we want last limits, should we do then something like this? Limit. Oh yeah, but with the oh my god. Okay, here it is. Sorry, my I will show you my keyboard and you will realize what that happened. I forgot where the dollar sign was. Uh, and yeah, we need to add a comma here. Search tester only supports a single search. Oh, okay, I see. So if we run this here, on the options or yeah, query object display. Okay. Yeah, of course, makes sense. I was just being crazy. But yeah, you see the point, right? If we perform a regular search on just the 1 week, we cannot find anything. But if we look for this misspelled, even if let's say we know like okay we know this needs to be capitalized same as the w, but I forgot to write an e, or the user forgot to write an e, and you search for this, you will see the result is the title the same. The object was to and civil exit a chapel as newildis. Um, so can you see the grayness of this? Can you see how amazing? And we even have reached the vectorial part yet, because this works with text amazingly. Let's discover on images and the embeddings that the movies actually have. But I see you have some questions. Let me see. Great with great keyboards comes great responsibilities. Hey, yeah, thank you so much. This is pretty good. Hey, like I like that you like it. Give me a second. I need to sneeze, and I don't want to do it like on camera. I'll be quick. Back. Oh my god, I'm back. Thank you so much. Hmm. So we already. Oh, where were we? We already created the search index, right? So create search index, choose JSON editor, select your database. Okay. Uh, uh, um, this is already created, but we can create a new search index so you can have a better understanding. What's happening here? This is an atlas search or a vector search, full text search for relevance based on app features. That it's the example we just saw. Or we have vector search for semantic search and AI applications, the next level. So let's do this. Index name and data source. The index name will be mm, 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 semantic search, vector index. Oh, well, let's leave it at vector index. Database and collections, sample inflix, embedded movies, and configuration model, JSON editor. Okay, let's do it visually for the moment. I think that will help. Okay, that's next. Now the vector field. Uh, 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 Fields type vector. This is also again how the if we choose here in the previous JSON editor, this is what we will need to. So the predefined one, it's type vector. We have type vector, path embeddings. Path, in this case, it's plot embeddings. What's the difference? Well, that's why we have here mob embeddings. That's the name of this value, right? Plot embedding. Um, we can add the plot embedding via tree large if we want. So yeah, what else? Type filter, path category, type filter, path date, right? This could be many. So let's do that with the visual editor. So it can be simpler, I think. The path, it's plot embedding, which is the one we have here selected. So number of dimensions, how we can notice length of the vector field, you must specify a value less than or equal to the max dimension allowed. So we got this. These are the two we have. By default, since we select the collection that we were wanted to host this, which is the embedded movies, the two values of the vector embeddings we were pre-detected. So if we select one that doesn't have, for example, regular movies, it says no vector embeddings were detected in these collections. You can still create an index now and then load the embeddings later. I mean, we trust you. If you say there will be embeddings there, go ahead, do your thing. But here, since they were already created and this is already existing, that's the advantage of that. That's why I mentioned about the loading the simple data, right? Imagine the time it could take us just to upload all of the data. uh, Not that much, to be honest, but not enough for the time at the stream. So we have the blood embedding selected, the blood embedding voyage tree selected. We could add another one, for example, a filter field, sorry, which is what we had here, like for example, a category or a date. So let's do that. Let's that the t- 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 languages right released. Released, it's today, right? I just want, okay, yeah, released. And the category could be something like the languages, because these are arrays of the available languages. So we can add the languages. So once we have configured that, I'm missing something. Do I missing something? Oh yeah, the similarity methods. The similarity methods we are having here, it's for example cosine. In this list, I'm going to choose cosine as well, and cosine for this. How does this perform, and how do I pick the right similarity method? Um, that's a great question. I'm not sure, to be honest. Choosing the right similarity method, check embedding model guidance, and most provide embedding model will recommend the similarity method based on what was using during the training. Embedded models were often optimized with a specific measure that aligns. If no guidance is provided, if your vectors are normalized, start with a dot product. If your vectors are not normalized, evaluate cosine similarity or gliding distance in the next step. I'm not. I'm not sure. Let's just start with the dot product then. Yeah, yeah. Let's do that. And now we can go next. This is the summary. Review search index for vector search, sample and flicks movies, the filter fields, create or vector search index. And we are creating this now. It's being released. This sample mflix with movies index was the default. It was created. It is just a regular search, not a vector search. With dynamic index fields was already done. While this loads, let's also this is a great note. You can have a limit of 3 search and vector index per cluster when you have an M0 for cluster. That's another reason why um, you can use your credits. So let's move to the configuration. Um, Path embedding, the field containing embeddings, number dimensions. Okay, this was what already we covered. Similarity, uh, create. Okay, now let's head to Voyage. And this is the first time I'm going to do the Voyage thing as well. So that's a new for me. Let's do that together. So we were here, Voyage. What is this? Single for account, navigate to the wiki section, create a new API, copy and secure. Okay, login. What do we need? Okay, let's use. Okay, I'm going to do this. Password generator. Okay, I'm going to do this offline because else this won't be that secure, right? Uh-huh. New item, login. Voyage. Oh yeah, of course. Two. I believe you. Okay. Here we are. So I'm going to create a new secret key, name, test global Hardwick project, default project, and I'm going to copy this and done. Now, um, create a new key, copy and save it. So this should look like Voyage. Is this Voyage Abbey? Voyage Abbey. And what I'm missing, um, oh yeah, database collection name. That's great things to have in mind, of course. Database, it's called, okay, this is ready to use. The index name, it's vector index. Okay, that was ready defined. Collection name, it's embedded movies. And the database, it's called sample mflix, right? So this is like really all sample data. So document schema. Document, it's the collection, follow its structure, object, title, content, the embedding, category, date, metadata, blah blah blah. This is not what I'm going to follow. Of course, oh, sorry, I lost track of the stream. But this is not what I am going to follow. Of course, we are using the sample mflix data, right? So how vector search works in this application. First, the ingestion. Load documents from your data source, generate embeddings using Voyage AI, store documents with embeddings. Search phase, use enters and natural language query. Queries convert to embedding using Voyage AI. MongoDB Atlas finds similarity. Vectors using cosine similarity results are ranked and returned. Sample vector search query. So this is how a vector query search can look like. Um, so, for example, what I like to do right now, it's doing this, but on Compass. So I'm going to open the embeddings ones. Indexes available? No. Documents, validation, schema, aggregations. No. Documents. So I'm going to open. That's a great question. I'm not sure how to do that on Compass. So let's ask Copilot, right? That's why this is the core. Okay, what? Um, Pair programmer, yeah. Can vector index we used on Compass. Vector search index from Atlas can be used on Compass? That's a good question. Let's discover. Also, if no, we can start making our queries here. So the B dot embedded mobiles and aggregation. Okay. Your pipeline is currently empty. An aggregation that has vector search, index, vector search, path, plot embeddings, query array of numbers, number candidates, number. Okay. To execute the full vector query, connect to the Mongo shell and copy the code below into an aggregation pipeline. You can also aggregation pipeline in the Explorer. Okay, here, yeah, or in Compass. So we copy this, we come to Compass, we okay, generate aggregation. I want to test vector search using Netflix dataset. I have this. Okay. Okay, great. So, stage one. Okay, interesting. Um, we can create a new, confirm, got it, now content generate, stage. Uh, huh. what I'm looking what I'm looking for here supposed to be vector search. Vector search, yeah. Stage value. What is this? The whole one? Okay, I'm going to create new one, confirm. Uh-huh. Oh, okay. And generate this again with the help of the AI they have here. Okay, got it. So we have this vector search thing. Interesting. Um, hey, Shelby, yesterday I was thinking about MLH hackathons and only saw this now. How is it going, Alberto? Awesome code. What are you cooking? Thank you so much. Also, that's a great thing. If you are planning to run a hackathon soon, let us know. We always are happy to help with that. It doesn't matter if the coach you're seeing on the stream or anything, it's like from your region. We're always glad to jump in and help you get started from your next hack, right? So let's try to wrap up this very quickly. Um, so, uh, 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 yeah, also Copilot, what does Copilot give us? Yeah, answer yes. What you can do in Compass. View collections. Now I'm going to ask, are you familiar we are with the Amplix dataset. It looks like this. And help me create a working query. Okay, we can close this. Have the embedded model. I'm going to copy this, and this is how it looks. And let's see. You see how these embeddings works? Um, plot embeddings, binary base, blah blah blah. So this is the binaries ones. And so following up the question I had previously about the if they behave different numerical and binaries, um, I will change my opinion on that. I will say the binaries are have better performance. Yeah, I thought about that during this session, and of course, it just makes sense. Like that's the main intention of having binaries, right? So, for example, Mongo, MongoDB doesn't have JSON, and instead it has BSON, which is binary JSON. So, totally makes sense. This also is binary. Um, so yeah, perfect. Based on the Netflix dataset structure you show me, here's a complete working vector search query. Vector search query for Netflix basic vector search. The index we were looking for, it's block vector index. Are you sure? Query index vector index. Okay, this shouldn't be without this, just vector index path, plot embedding. Yeah, makes sense. Query vector, your query embedding array. So how we create the query vector, that's interesting, right? Uh, so let's do this. The query vector. Okay. Now let's create an app that uses Voyage AI to perform these queries for a semantic search. Use Node.js and the amps in the file. And I'm going to add the file folder semantic search. So yeah, we need Voyage AI to give the query vector, which also it's the vector embedding. That lets me where I mentioned you needed to put the pin, Juan Ayed, about the where no, so the original question here. So the original data and the question, in this case the query, both needs to come back to vectors. Answer again, it's yes. The short answer in the moment was yes. I tell you to put the pin on that for telling you how to do this using Voyage. And again, I love this image because of that. You get the chance to see how the query goes to the vector embedding model, looks for the embedded vector database, how the data before being stored goes to the embedding model, and then it's stored to the vector database. Then we use the rankers to pass this to the LLM function to help save some time. In those cases, we add the queries using the re-rankers. It's not needed to use the embedding model or having to embed this. That's the point of using the re-rankers, right? In this case, we didn't implement them, so that's why we're needing to do this. Huh. So, yeah, let's allow. I'm also short of running out of time, so I'm going to take advantage to skip to this part. Um, Again, you already have the repository. It's Albert47 Global Hack Week or GHW vector DB, right? Here you can find the instructions for the semantic search we were looking, all the explanation on how to set up your Atlas vector search and the index we mentioned. And one thing we didn't cover because of the time was the retrieve augmented generation. So, for example, for you, Abdul, I think that will be really helpful. Um, but it's almost the same, right? I have to admit that it's almost the same, um, and that's it. So let's wait for this to be installed. Uh-huh. Oh my God! Don't tell me that. No, I'm going to do this super quick. I promise. Um, if my internet allows it, of course. Okay. Also, I'm going to take advantage since we don't have a follow. Yeah, the next stream will be in too many hours, so I'm going to take 5 more minutes from your time if you want. I mean, you're totally free to leave. And before you leave, of course, I like to share with you something, which is the mlh.link slash global hack with feedback link. I think that's, yeah. Um, this is the link. So please share your thoughts with us. Help us understand what we did great, what we did not so great, and how we can improve. Yeah, we have the back. Yeah, let's do that. Let's do that. Agree. Install. Let me move. Okay. Close. Yeah. So now let me to include the scripts allowed. CD semantic search, and here npm install. Okay, everything was installed. This is great. Some other things. Excellent. Summary. Okay, we reached this point, so let's just explore. Okay, this can keep. I'm going to actually copy and paste this on the base git ignore. README and flexible research makes sense. Usage, okay. Package JSON, just it's what we wanted. PHEI, vector search, MongoDB, semantic search, and mflix. The index uses .mconfig for PHEI client and MongoDB client. Okay. Now there's README. I think this is like probably not what we want. Yeah, so I'm going to delete this README. Oh my god. No, this actually was something I want. So, well, my bad. Um, let's keep this and let's run it. Now npm run search. Okay, this has a problem. For each client, it's not a constructor. On index, yeah, on the index one. And okay, we have that saved. This we have the API key, quick start, vectorize, import, quick start, text embeddings. Probably this is better on Python, right? Okay. Hmm. API references or the this library. That's interesting. Um, Great. I think we have our working application now. So I'm going to hide this. Sorry. Um, Use natural language to describe the movie plot. For example, uh, let's do one more thing. A movies here on our previous case of the text sample Netflix on the default one, we're going to query. Can you share the committed files? Yeah, I'm going to share them. I'm going to create a new commit and push them. Uh, Here on the search, no, sorry, on the query, create from template with typos, insert the path. Again, it's title, and this is going to be metrics. And let's search for that. Let's see if we have a movie that's called The Matrix. Yeah. So the plot: a computer hacker learns from mysterious rebels about the true nature. Okay, how we can do this? Use natural language to describe the movie plot. Uh, dystopic world where you live inside a computer program. How many results? Five. No filters, and let's look for this. Search error. Plan execution error. Random variation caused by vector search is indexed with required. Oh, okay, this is interesting. We need to update. Okay. Uh, huh. That's very interesting. Because we can look for 024. These all are readmes, usages, and things. Um, okay, let's see. VH large, put model. Okay, interesting. Keep search query for from search, and I'm going to do that again. This topic 5. No filters. Plan execution. Okay, same error. And now what I'm looking for, it's going to be here. Hmm. Uh, Vector field is indexed with these dimensions, but queried with these others. Maybe what I need to do is update here the query edit to modifying the auto-populate number and nationality made of indexing only documents that contain a specific. Okay. No, they no. Then no. Okay. Oof. I'm running out of time. Um, Here it is, 136. That's what we wanted, isn't it? 136. Okay. Um, that's a good question. Which version should we use? Okay. Nope. Okay. Well, let's try to do this manually. Uh, let's open index model voyage docs channel discussion model. Repository usage input model client. Yeah, that works. The problem here could be the model input text input type query advanced model. Which model? It doesn't tell us. Okay. Same error. Semantic search. Okay. Okay, this app written so it's overkill. This or it's overkill. Task connection. Search. Index. Check indexes. Oh, I'm getting a message. I don't know what was that. Okay. Perfect. So yeah, this was the model. Uh, on our first score was Riddick, which, if you know the movie, actually makes sense. Um, Automata, Mesrine Part 1, Transformers, Age of Extinction, and Vanilla Sky. Okay, okay, let's try to focus the a dystopic world where computers, where machines feed from humans electricity and hackers fight against them. Let's see. Okay, Hero Wanted, The Mummy Returns, Ghost, Me and Him, Another World. Let's try it with the description that it says here, like the Matrix title. It was The Matrix. I think this was how it was spelled. Let's just see on the plot. A computer hacker learns from mysterious rebels about the true nature. And still Resident Evil. Okay, looks like the looks like the actual plot embeddings and plot embeddings and Voyage Launch aren't like throwing the exact information that we wanted here. But hey, you see now how this works. Um, so the point and the juicy part here, it's not that in the how um, how we create this program to be used. It's also in the what embedded model we use, as you can see here, to store that information and to make sure that the embedded vector actually gets the intentionality, the meaning of what we're trying to say, that's stored in the binary array that we're storing, right? um, so that's into the vector embedding. Hope this lesson teaches you something. Hope that you now understand how easy actually it's to implement great searching capabilities with Atlas indexes, with the capability of MongoDB of storing vector embeddings. And well, that was it. Let me close this. Um, one one ID. Yeah, I will commit this into the repository I just shared. You will see the update at the end of the session, which is in like 2 seconds. Thank you so much for joining me. This is the only session I'll be giving for this Global Hack Week. Unfortunately, I didn't have enough time to prepare more sessions to deliver more content. So I love being here. I love streaming on Global Hack Week, but I also like to spend more time doing nothing, like relax a little more. So thanks so much for joining me. Hey, thank you. Session was really informative. I learned a lot today. Hey, thank you. That makes my day. So with that, I can wrap up. Well, let's see you in the next level hack week. Me, but you can continue enjoying on great streams, right? Remember, we have Ridby coming up with using open source LLMs, and don't forget to share your feedback. And I will see you in future sessions. Bye bye.